Welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 704. This is binary search. And for this problem, we're going to be given an array of numbers, nums, and it is sorted in ascending order. And we're also going to be given an integer target. And we need to write a function where we find the target in our nums and return the integer of target. Otherwise, we are going to return -1 if it's not in our array. So the specification for this problem is that you have to write an algorithm in O log n runtime complexity. So what is this problem asking us to do? Well, we're given our array for this example 1, we're given our array nums and our target of 9. So we want to see if 9 is in the array. So we can see that 9 is in the array and it's at index 0, 1, 2, 3, 4. So 4 is our output. And then for example 2, we're given this array and we want to find the target of 2. So we look and we see, is there a 2 in the first place? Is there a 2 in the second place? No, 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 no. We don't see a 2 at all. So we're going to return -1, and that's the answer. So how can we solve this problem? Well, we're constrained by our runtime must be O of log n. So we can't just scan the array and loop through the array and look for the target number, because that would take O of n time to scan the array. So we're told that we must write an algorithm in O of log n time, and we're also told that it is sorted. So what we should immediately be thinking is, if we have to do this in O of log n time and we're given a sorted array, is we should immediately be thinking binary search. And in fact, that's the name of this problem, binary search. So that kind of gives away what we're going to need to do. So we're going to need to do binary search. So I will show you the algorithm for binary search. So this is our array. With our input array, we're given the numbers -1, 0, 3, 5, 9, and 12. And I also put the indices for the numbers for simplicity's sake. And so binary search is an algorithm where we're going to capitalize on the fact that the array is sorted. So if our target is 9, we will start in the middle. So we'll start at 3. And we will look and we'll say, is 3 less than our target, or is it greater than our target? So we're using the fact that our array is sorted to be able to determine where our target is. So is 3 less than our target or greater than our target? It's less than our target. So we know that we are not going to be able to find everything less than 3 is going to be this direction. So if our number that we're currently on is less than our target, then we know that we can't find it here and we can't find it here. So we're going to eliminate these. So we eliminate those. And So now we we're going to start a new midpoint, and our new start is going to be, we know we don't need to look at 3 anymore, so we're going to start the next number after 3, and our new end is going to be, we're going to keep our end the same. And now we're going to, now we're going to look, and our midpoint is going to be 9. So we can remove this 3. We can remove the red from the 3. So our midpoint is 9, and so now we found our number. So that took O of log n time, because for every time we're running the algorithm, we're going to be cutting our result in half and in half again. So it's not, we if this was our midpoint, we cut this in half, and then say our answer was 12, what our target was 12. If we had the midpoint of 9, we would cut this whole side of the array in half, and then we would end up finding our target in O of log n time. So that is the algorithm for solving that problem. So let's see it coded up. Actually, before we move on, let's show an example where the target is less than the where the target is less than the midpoint. So this was 3, this was 9, and now let's make our target -1. So we can start, we will have our start here and our end here. So we have our start and our end, and we make our midpoint. We get our midpoint, and our midpoint is 3. Now, is 3 less than our target? No, it's not less than our target. Is 3 greater than our target? Yes, our midpoint is greater than our target. So we know that our target, we're going to find our target. We can't find our target this direction because all these numbers are going to be greater than 3. So if our midpoint is greater than our target, then we can totally eliminate all of these and this one. So therefore, we can move our end position to be here. So we move our end here, and we make our midpoint here. Now, and now our mid matches our target, so we found the answer. And so that's how that algorithm will work. And let's see it coded up. So the first thing that we need is we need our pointers for our start and our end. So we're going to have a start, and it's going to start at index 0, and then we're going to have our end pointer, which is going to start at the length of our nums -1. So it's going to start at the last number. And then we're going to loop, and we're going to stop our loop when our end pointer is, so we're going to loop while our end pointer is greater than or equal to our start pointer. So as soon as our end pointer becomes less than our start pointer, that means that we've run out of numbers to look at. So while our end is greater than our start, we are going to do our loop. And we are going to get our mid, which is going to be our start plus our end minus our start divided by 2. And this does the same thing as start plus end divided by 2, but it actually prevents you from having an overflow error. So this is just a better way to get the midpoint. So this will give us our midpoint. Now we want to check if our number at mid is greater than our target. If our number at our mid is greater than our target, then we know that our number is going to be to the left. And so what we need to do is move our end pointer to be equal to our mid, and our mid minus 1, because we want to have it to the left of what our mid was. And else, if our nums at our mid is less than our target, if our number at our mid is less than our target, then we know that our answer is to the right. So we want to move our start to equal to our mid plus 1. So the next number after our mid, we're going to start there and look for our answer. And else, if neither of those are true, then that means that our nums at mid is actually equal to our target, and we want to just return our mid, which is our index. We want to return the index that we're on. And if we get through all the numbers and we haven't found our target, we're just going to return -1 as our default answer. So that is the code. So let's run it and see what happens. So this is giving us the right answer. Let's submit. And we can see that it was accepted, and it is faster than 99% of all Python submissions. So it's pretty quick. And that is how you do binary search. Thanks for watching, and I'll see you in the next video.